Welcome to this comprehensive guide on finding the area of parallelograms. I'm excited to take you through this fundamental geometric concept that appears everywhere in mathematics and real-world applications. Before we dive into calculations, we need to understand exactly what a parallelogram is. A parallelogram is a four-sided polygon where opposite sides are parallel and equal in length. Notice the key properties. Opposite sides are parallel, shown by these arrows, and opposite sides have equal lengths. This makes parallelograms a special family of quadrilaterals. Now, what exactly do we mean by area? Area represents the amount of two-dimensional space enclosed within the boundaries of our parallelogram. Think of it as how much surface the shape covers. The fundamental formula for finding the area of any parallelogram is A equals B times H, where A represents the area, B is the length of the base, and H is the perpendicular height. This formula is incredibly useful in many real-world situations. Architects use it to calculate floor areas, farmers use it for field measurements, and engineers apply it in structural design and physics calculations. In this comprehensive tutorial, we'll master the basic formula, explore alternative methods using angles and diagonals, and work through progressively challenging examples. By the end, you'll confidently solve any parallelogram area problem you encounter. Now that we understand what a parallelogram is, we need to identify two crucial measurements that will help us calculate its area: the base and the height. First, let's identify the base. The base of a parallelogram can be any side of the shape. It's important to understand that we have flexibility in choosing which side to call our base. Now comes the critical concept: the height. The height is the perpendicular distance from the base to the opposite side. Notice I said perpendicular distance. This is key to understanding the concept correctly. Here's where many students make a common mistake. The height is not the length of the slanted side. Let me show you the difference clearly. The key difference is that the height must be perpendicular to the base. Perpendicular means forming a 90-degree angle. The slanted side is not perpendicular to the base, so it cannot be used as the height. Now let me demonstrate something important. We can choose any side as our base, and the height will always be the perpendicular distance to the opposite side. Watch what happens when I choose the right side as our base instead. The height is now the perpendicular distance from this new base to its opposite side. Notice that regardless of which side we choose as the base, the height is always measured as the perpendicular distance. This perpendicular relationship is fundamental to calculating the area correctly. Let me summarize the key points about base and height that you must remember for calculating parallelogram area. First, the base can be any side of the parallelogram. Second, the height is always the perpendicular distance from the base to the opposite side. Third, the height is never the length of a slanted side. And fourth, base and height must always be perpendicular to each other. Understanding these concepts about base and height is essential before we move on to applying the area formula. In the next section, we'll see exactly how these measurements work together in the area calculation. The area of any parallelogram can be calculated using a simple but powerful formula: A equals B times H, where A represents the area, B represents the base, and H represents the height. To understand why this formula works, we need to clearly identify the base and height of our parallelogram. The base is any side of the parallelogram, and the height is the perpendicular distance between the base and the opposite side. Here we can see the base B, which is the bottom side of our parallelogram, and the height H, which is the perpendicular distance from the base to the top side. Notice that the height is not the same as the slanted side length. But why does this formula work? The key insight is that any parallelogram can be transformed into a rectangle with the same base and height, and therefore the same area. Imagine we cut off this triangular piece from the left side of our parallelogram. This triangle extends beyond what would be a perfect rectangle. Now, we take this exact same triangle and attach it to the right side of our parallelogram. Watch what happens to the shape. Perfect. We now have a rectangle with exactly the same base and height as our original parallelogram. Since we only moved the triangle from one side to the other, the total area remains completely unchanged. Since the area of a rectangle is simply base times height, and our parallelogram has the same area as this rectangle, we can confidently say that the area of any parallelogram is also base times height. Remember these key points. The base can be any side of the parallelogram. The height must be the perpendicular distance between parallel sides. And this formula works because any parallelogram can be rearranged into a rectangle with the same dimensions. The area is always expressed in square units. So our fundamental formula for the area of any parallelogram is A equals B times H, where A is the area, B is the base, and H is the height. Now that we understand the basic formula for finding the area of a parallelogram, let's work through our first example step by step. Here's our problem. We have a parallelogram where the base measures 10 yards and the height measures 6 yards. We need to find the area. First, let's visualize our parallelogram. Remember, a parallelogram has opposite sides that are parallel and equal in length. Now, let's identify the base of our parallelogram. The base is the bottom side, which measures 10 yards. Next, we identify the height. Remember, the height is the perpendicular distance between the base and the opposite side. This measures 6 yards. Now we have all the information we need. Let's apply the area formula step by step. We start with our area formula, A equals base times height. Step 1, we substitute our known values into the formula. Base equals 10 yards and height equals 6 yards. Step 2, now we multiply 10 times 6, which gives us 60. Notice that our answer is in square yards because we're measuring area. This is a crucial point to remember. Area is always expressed in square units because we are measuring two-dimensional space. So our final answer is 60 square yards. This example demonstrates the direct application of the area formula for parallelograms. Looking at our parallelogram again, we can see that by multiplying the base of 10 yards by the perpendicular height of 6 yards, we get the total area of 60 square yards. This straightforward example shows how easy it is to find the area when you have the base and height measurements. In our next example, we'll explore a more complex scenario. Sometimes when finding the area of a parallelogram, the height isn't directly given to us. Instead, we might know the lengths of two adjacent sides and the angle between them. In these situations, we need an alternative approach. Here we have a parallelogram where we know the lengths of two adjacent sides, but we don't have the perpendicular height measurement. We'll call these two adjacent sides A and B. Side A is our base, and side B is the adjacent side. The angle between these two adjacent sides is theta. This is the key piece of information we'll use in our alternative formula. The alternative formula for finding the area of a parallelogram using adjacent sides and the angle between them is area equals A times B times sine of theta. Let's break down what each part of this formula means. A and B are the lengths of the two adjacent sides we know. The sine of theta is the trigonometric function that helps us find the effective height of the parallelogram. This is the key that makes this formula work. Now let's understand why this formula works. The key insight is that sine of theta gives us the relationship between the slanted side and the perpendicular height. In this right triangle, we can see that sine of theta equals the height divided by side B. Rearranging this relationship, we get height equals B times sine of theta. Now we can substitute this expression for height into our original area formula. Since area equals base times height and height equals B sine theta, we get area equals A times B times sine theta. This alternative formula is particularly useful when you're given the lengths of two adjacent sides and the angle between them, but the perpendicular height is not provided. The sine function automatically accounts for the angle and gives us the correct area calculation. Now we'll work through our second example, which demonstrates how to find the area of a parallelogram when we know two adjacent sides and the angle between them. Here we have a parallelogram with two adjacent sides measuring 5 units and 8 units, with a 60-degree angle between them. When we don't have the perpendicular height directly, but we know two adjacent sides and the angle between them, we use the formula area equals A times B times sine of theta. First, we substitute our known values into the formula. We have A equals 5, B equals 8, and theta equals 60 degrees. Next, we need to find the value of sine of 60 degrees. From our trigonometry knowledge, sine of 60 degrees equals square root of 3 divided by 2. Now we substitute this value back into our equation. Area equals 5 times 8 times square root of 3 divided by 2. First, we multiply 5 times 8, which gives us 40. Finally, we multiply 40 by square root of 3 divided by 2. This simplifies to 40 times square root of 3 divided by 2, which equals 20 square root of 3. Therefore, the area of our parallelogram is 20 square root of 3 square units. This is approximately 34.64 square units. This method works because the sine of the angle gives us the ratio that relates the slanted side to the perpendicular height. When we multiply the two adjacent sides by the sine of the included angle, we effectively calculate base times height. This completes our second example. We've successfully found the area using adjacent sides and the included angle, demonstrating an alternative approach when the perpendicular height isn't directly given. Now we'll explore another powerful method for finding the area of a parallelogram using its diagonals. This approach is particularly useful when you know the lengths of both diagonals and the angle at which they intersect. The formula for finding area using diagonals is area equals 1/2 times d1 times d2 times sine of y. Here, d1 and d2 represent the lengths of the two diagonals, and y is the angle between them. Let me show you visually what these diagonals look like in a parallelogram and how they intersect. Here we have a parallelogram with vertices labeled A, B, C, and D. The diagonals are the line segments that connect opposite vertices. The first diagonal, D1, connects vertices A and C. The second diagonal, D2, connects vertices B and D. Notice how these diagonals intersect inside the parallelogram. The angle y is formed where the two diagonals intersect. This angle is crucial for our calculation, as we need its sine value in the formula. Now let's work through a concrete example to see how this formula works in practice. Here's our example problem. We have a parallelogram with diagonal D1 equal to 12 units, diagonal D2 equal to 16 units, and the angle between the diagonals is 30 degrees. We need to find the area. Let's solve this step by step using our diagonal formula. Step 1, we start with our diagonal formula. Area equals 1/2 times D1 times D2 times sine of y. Step 2, we substitute our given values. D1 equals 12, D2 equals 16, and y equals 30 degrees. Step 3, we need to calculate sine of 30 degrees. Sine of 30 degrees equals 1/2, or 0.5. So we substitute this value into our formula. Now let's complete the calculation. Step 4, let's complete the calculation. First, we multiply 12 times 16 to get 192. Then we multiply 192 times 0.5 to get 96. Finally, we multiply 1/2 times 96 to get our final answer of 48 square units. This diagonal method is particularly useful when you don't have direct measurements of the base and height, but you do know the diagonal lengths and their intersection angle. It's another powerful tool in your geometry toolkit. In our next section, we'll explore real-world applications of these parallelogram area formulas and see how they're used in practical situations. Now that we've mastered the mathematical formulas for finding parallelogram areas, it's time to explore how these calculations apply to real-world situations. Understanding these applications will help you see why parallelogram area calculations are so valuable in many professional fields. Our first application is in agriculture, where farmers need to calculate the area of their fields for crop planting, irrigation systems, and land valuation. Many agricultural plots are parallelogram shaped due to natural boundaries like rivers, roads, or property lines. In construction, parallelogram area calculations are essential for determining material requirements. Architects and builders use these calculations to estimate the amount of flooring, roofing materials, or wall coverings needed for projects with non-rectangular shapes. In physics, parallelogram areas appear in vector calculations, force diagrams, and electromagnetic field studies. The cross product of two vectors creates a parallelogram whose area represents important physical quantities like torque or magnetic flux. Now for our comprehensive recap. Throughout this video, we've explored three powerful methods for calculating parallelogram areas. Each method is useful in different situations, depending on what information you have available. Method 1 is the basic formula. Area equals base times height. This is your go-to method when you know the base length and the perpendicular height of the parallelogram. Method 2 uses adjacent sides and the angle between them. This formula is area equals A times B times sine of theta, where theta is the angle between the two adjacent sides. Method 3 uses the diagonals and the angle between them. The formula is area equals 1/2 times d1 times d2 times sine of gamma, where gamma is the angle between the diagonals. The key to success with parallelogram area calculations is choosing the right method based on your given information. Always identify what measurements you have, then select the most appropriate formula. Remember that all three methods will give you the same result for the same parallelogram. They're just different paths to the same destination. Practice with each method to build your confidence and mathematical flexibility. Thank you for joining me on this mathematical journey through parallelogram area calculations. You now have the tools to tackle any parallelogram area problem, whether it appears in your homework, on a test, or in real-world applications. If this video helped you understand parallelogram areas better, please give it a thumbs up and subscribe for more mathematics tutorials. Leave a comment below if you have questions or suggestions for future topics you'd like me to cover. Keep practicing these formulas, and remember that mathematics is all about building understanding step by step. Until next time, keep calculating and keep learning.